Hello and welcome to Supnit's classes. So today we'll be discussing about some level 2 JEE exercises on chemical bonding chapter. So as we can see, we'll right away delve into the topic. Our first question over here is stated as the correct stability order of the resonance structures are to be found out. So when we compare the stability order of various resonating structure, our first and foremost point that you need to find out is the total number of bonds. So whichever structure will have lesser number of bonds will be definitely less stable. So we'll just find out. So if you see at this moment, if you see this option and this option, in both this option we can easily understand the number of bonds is number 3, and in the top two options it is 4. So definitely this will be less stable. So 3 and 4 first I will compare. So in 3 and 4, if I compare on the nitrogen atom in option number 4, we can easily see there is a positive charge on the electronegative atom. So that is not the case in case of option number 3. There is negative charge on electronegative atom and the positive charge resides on the carbon atom. So what will happen? Our number 4 option will be occupying the least stable position. So I'll write number 4 is the least stable. Then number 3 will be stable than number 4. After this I'll compare the number 1 and number 2. In number 1 on nitrogen, if you see on nitrogen there is a positive charge, and on another nitrogen there is a negative charge, but in number 1 the positive charge resides on nitrogen and the negative charge resides on carbon. Carbon having negative charge is not that stable, so definitely our option will be 2 more than 1 more than 3 more than 4. Our next question over here is species having pyramidal shape. So answer to this question will be OS2, OSF2, this one. So first of all, let us go through the shapes, then we will be able to understand this in a better way. So if you consider OSF2, the structure will be like this: S double bond O, F, F. After this also there will be a lone pair over here like this. So this will give you the pyramidal shape because this lone pair is pushing this bond pairs in the downward side, as you can see. So this is basically sp3 hybridized. Sulfur over here is sp3 hybridized. However, one is a lone pair, so when you are talking about the shape, we will consider only the atomic bonds, that is the bonds, the bond pairs will consider. And if you consider the bond pairs, then you can see that this is pyramidal shape. Other than this, like SO3, if you take SO3, this will be sp2 hybridized trigonal planar structure. If you take BrF3, then also it will not show your, we can check BrF3, so that we will have some practice on. So just first we will just draw a structure like this. So 3 electrons are gone, 2 lone pairs are there, so this will have a structure like this. So this is, if you see the hybridization of this 1 2 3 4 5, it should be sp3 dehybridized. So Br, the lone pairs will occupy the equatorial position like this, and F, F. So ultimately BrF3 is nothing but it is a T-shaped structure. BrF3 is a T-shaped structure. On the other hand, if you take this SiO3 2 minus, that will also have a trigonal planar structure. Okay, so overall our answer is OSF2. Okay, you please practice the other ones also, otherwise you are not going to understand the structures, how to draw the structures and how to find out the shapes. Please practice all the options. Coming to the next question: which of the following molecules is represented by Lewis structure? Okay, single Lewis structure. We know that in case of ozone, this is already known to us. In case of ozone, we have resonance, so definitely this will not be an option. I'll go for NOCl, check out. So if I draw the structure of NOCl, this will be the structure of NOCl. Now here oxygen is having 3 bonds, nitrogen is 2. So definitely this will not be the structure, this will be the structure. So if you see this molecule, then you can understand that the bonds are taking care of the octets of all the elements. So this is not going to have any further Lewis structure. This can be represented by a single Lewis structure, NOCl. Okay, understood. Next question. Which of the following can act as a nucleophile? So if you see, you have to draw structures over here. If you consider this BF3, boron is an electron deficient compound, this BF3, because it is having sextet over here, 6 electrons. So electron deficient compounds are always electron loving, so it will be electrophile, it will not be a nucleophile. So out of question. H2O, if I draw H2O diagram, then it has 2 lone pairs. So whoever is having lone pairs can act as nucleophile. Now, lone pair of electrons means it has electrons, it is going to love nucleus, so it is a nucleophile. So here the answer will be H2O. Okay, this is a very nice question, involves a lot of geometry inside it, and I like this question very much. So carbon carbon single bond distance is 1.54 angstrom. Okay, what is the length of the polymer molecules having 101 carbon atoms bonded in a straight chain? So we know this very well, that carbons are bonded tetrahedrally. So the angle between this is 109 degree 28 minutes. So let us draw this triangle first. So this is a triangle like this, right? So if you see this angle should be 54.5 degree approximately, and this length is given. So this is carbon number 1, right? This is carbon number 2, and this is carbon number 3. So I am going to find out this distance first. This angle is known to me, and this distance, bond distance, is also given as 1.54 angstrom. So likewise over here there is 101 carbon atoms. So I am taking only 2 carbon atoms over here. I am trying to find out this distance. So if you consider this angle, this will be height and this will be hypotenuse. So I can easily find out this height is equal to hypotenuse, that is 1.54 into sine 54.5 degree. So this value is given over here, 0.8164. So if I multiply 0.8 with 1.54, so I'll get a value of around 1.25 angstrom. Okay, so as soon as I get this value, I know what is the distance between 2 consecutive carbon atoms. Now at this moment I am having 101 carbon atoms, so carbon carbon bond will be 100 only, right? Carbon carbon bonds will be 100 because there is total 101 carbon atoms. Because if there was 2 carbon atoms, then how many bonds were there? 1. If there is 3 carbon atoms, number of bonds is 3, number of bonds is 2. But if there are say 101 carbon atoms, the number of bonds will be 100. So one bond length is 1.25, so 100 bond lengths will be 125 angstrom. So this will be the answer. It's a very nice question. It involves some trigonometry and geometry inside it. So nice to solve. Please practice this kind of question. It is a creative question. It involves a lot of inquisitiveness in us to link between subjects, which is important. Okay, next question, another very important question. Which is of the correct sequence? I think there is some grammatical mistake over here. Which is the correct sequence of decreasing OO bond length? Okay. So see, when I am considering O2, O2's bond order is 2, O3's bond order is 1.5, and H2O2 bond order is basically 1. So bond order is inversely proportional to bond length. So definitely bond length will be highest in H2O2, then ozone, then O2. So option A will be the correct option. Okay, so this is an easy problem. Okay, this is another nice question. Let us see this one. Which of the following statement is correct about the molecular structure of boron trifluoride? Okay, in boron trifluoride, one of the important study of this compound is, see here, boron does not form an octet. So to gain octet, boron accepts the lone pair from the fluorine to form a special kind of bond which we call as back bonding. Correct? Which we call as back bonding. So hence this kind of structure appears. This is not a structure or not the correct structure. Okay. Now this is the structure. The number 1 is a structure which is not fulfilling the octet. So this will contribute very less towards the resonance hybrid. So option A is saying that all the structures are contributing equally to the resonance hybrid. This is not acceptable, right? Next, structure 1 contributes maximum. Absolutely not acceptable. Structure 2 to 4 contribute to a greater extent to the resonance hybrid. Well, kind of correct, but they contribute equally to the resonance hybrid within themselves. Okay. Next option is option D. BF has not been found to possess pi character, is not expected to be in canonical form. So this is a correct option, because what it means to say is, here there is again some grammatical errors, spelling mistakes. What this means to say is that this BF bond, this one has no pi character, so it is not expected to be in the canonical form. So in actual canonical form, it was found out that these BF bonds are having pi character due to this back bonding. So that is why this part is not to be expected in the canonical form, which we already discussed in the first hand. So done. Okay, next question. So in this question there is a small mistake. This will not be there. Which of the following structures of hydrazoic acid is N3H, is not expected to be in the canonical form? Nice question. So if you see over here, I am going to choose the option which is having least stability. So here if you count the number of bonds, everyone is having equal number of bonds, if you see. So I cannot really differentiate by that. However, if we see structure number 3, here two positive charges are lying adjacent to each other. Now when two like charges lies adjacent to each other, there is high repulsion between them, and that is not at all stable. So number 3 is not an canonical form. Which of the following is not expected to be a resonating structure? Another very good question. Which of the following is not expected to be a resonating structure? So how I am going to find out this? Okay. So first of all, one by one I have to take care of this. Number of bonds differs in all this. This is formal charge is there. Here there is negative charge. This is correct. You have to count the number of lone pairs. 1 2 3. Okay, 1 2 3 correct. 1 2 3 correct. Here there will be 2 lone pairs again. This will be 2 lone pairs. Question number 22. So which is not expected? We also have to see if there is any like charges, negative charges on positive. Yeah, got it. So here there is a negative charge on an electropositive atom and a positive charge on electronegative atom. Negative charge on electropositive atom and positive charge on electronegative atom is not stable, so we'll go for option A. Clear? So one by one you have to find out, you have to do the problems, and then you are going to find out. So don't jump into conclusion. One by one, step by step, number of bonds, number of electron pairs, like charges on adjacent atoms, electronegative atom, if having any positive charge on it, it will be considered unstable. Likewise, you have to move forward. Increasing order of dipole moments. Now dipole moments we have studied. So what will be the increasing order of dipole moments, we have to find out. So let us draw all these structures. CF4, NH3, NF3, we can guarantee that CF4 will be having zero dipole moment, perfectly tetrahedral structure. So all these options having CF4 in the list position, so it doesn't make any difference really. Next we will go for, say, let us compare these two. So in NH3 all the dipole moments are going upwards like this, but in NF3 there is cancellation of dipole moment. So NH3 must be having more dipole moment than NF3. So NH3 must be having more dipole moment than NF3. So we'll choose out those options first. This is correct according to what we are doing. This is wrong. NH3 cannot have less than that. This is wrong. So this too is a possibility. Now what will take care, we'll have to check out what is the difference between NH3 and H2O. So if you see H2O dipole moment, this will be approximately 104.5 degree. This is the dipole moment of H2O, and NH3 there are between H and N. So see, oxygen's electronegativity is much lesser than nitrogen. So definitely in that case H2O will have more dipole moment than the NH3 part. So H2O will lead over here. So option D is the correct option. Last question of today's video: the correct order of decreasing dipole moments in the following molecules. So I have already drawn the molecules over here. So we know very well that CCl4 will have a simple tetrahedral structure, and definitely that is going to have a dipole moment of 0. Other structures like CH3Cl, CH2Cl2 and CHCl3 have been drawn over here. So let us compare. In case of CH3Cl, so I'll draw it over here. In case of CH3Cl, there is a single dipole moment of X like this. But in case of CHCl2, if you see, there will be a cancellation effect. There will be a cancellation effect. Some part of the dipole is going to get cancelled. So that is what happened over here. One part of the dipole is going to get cancelled. So definitely CH3Cl is going to have more dipole moment than CH2Cl2. So this part is correct. And this is also correct. In case of CHCl3, more cancellation is going to happen, and definitely in that case this will be much lesser than CH2Cl2. So here option C is correct. Okay, so we have discussed lot of questions on chemical bonding. In next video some other questions of chemical bonding are also going to be discussed. So till then, please go on practicing chemical bonding so that you can do well in the upcoming examinations. Thank you.